Hey, what's up, guys? Chung here again. So today, let's take a look at another LeetCode problem. 362, design heat counter. So, sorry. So this one is like a design problem, right? Basically, okay. So you're asked to design a heat counter, which counts the number of heats received in the past 5 minutes, right? And you need to implement two methods. First one is the heat, and the parameters is the timestamp, which is the integer starting from 1. And also a get heats. Get heats, basically it passes a current timestamp, right? And uh, and to get the current from the current timestamp, what's the how many what the total heats in the past 5 minutes. And you're guaranteed that the system is chronological order. That is, the timestamp is always increasing, monotonically increasing, right? And then, okay, so for example here, so heat one, basically you store a one in this like class, two another heat, three another heat, at second three here, and at time four, you try to check how many heats so far, right? So in this case, we have three heats, one, two, three. And then we got another heat at 300 seconds, right? And then we try to get the heats uh, by at 3 seconds, right? 300 seconds, and then we have four, one, two, three, and four. And then if we try to get like the heats on 301, right? Then the first one, the one the one got hit on the second non-timestamp one got is no longer within the five minutes range, right? That's why we'll only have three. One, two, and three, and three. Yeah. Okay, pretty straightforward, right? And notice here is roughly that several hits arrive roughly at the same time, right? Okay, so I think the very naive way of doing this is basically we just have a list to store all the hits, right? And for each of the hits, we have a timestamp on it, right? For every time we have a hit, we just store that, and every time we have a heat, we simply add that heat into the list. And when we have a count, when we have like a get hits request here, we just loop through the list, right? We loop through the list until we ignore all the basically all the hits uh, earlier than this current time minus the 5 minutes, which is 300, right? And then we summarize everything after that. But the issue is, what if the numbers hits per second could be very large? Does your design scale, right? So that's the problem. So if we have like millions, like tens of millions hits per second, right? In that case, so that list could be huge, right? Basically, our solution won't scale. So what's the way of how can we scale, right? Notice that we're only counting for the last 5 minutes. So 5 minutes equals to 3 seconds. Oh my, okay. Uh, so 5 minutes equals to 300 seconds, right? Which means we can store the counter, how many counts per second, right? So so all we need is to store how many hits per second, even though let's say there are like millions of hits on second two. So this one will only be storing this number here, right? And in that case, no matter how many hits per second, will be basically the time and the space complexity is limited to the 300. Okay, with that in mind, then how can we design like a data structure for this, right? So I think the idea here is that we use a bucket, right? Basically, we create a, a array, a list with 300 elements to store the, the time, of that, and another another 300 length array, a list to store the count of that time, right? But one thing to notice that uh, the time could be more than 300, right? So how can we solve that problem, right? Basically, every time when we have a timestamp here, right, we do this timestamp mod by 300, right? And we use this one as an index to set the values in this in our two list. And in the end, when we try to get a hit, right? Basically, we just like I said, we just use the current timestamp minus the 300, and we look for anything. We try to summarize everything in the current list that's the time is greater than this time range, right? Um, okay, I'll try to explain a bit more what I'm coding here. So basically, we're gonna need uh two two lists here. The first one is the time. Okay, time 300, and the second one is going to be the count of the time. Okay, it's also 300 length. So basically, every time when we have a hit here, right, we'll get index first. The index is going to be the current timestamp uh, mod 300, right? And then we do two things here. Uh, okay, so first we check if the self time dot index, right? If this thing it's not does not equal to the our timestamp, right? Then in this case, okay, we know, okay, so this the current value has already moved out of the timestamp, right? So why? Because let's say this index is one, let's say the timestamp is 400, right? And the index is what? 100, right? So for this time bucket, right? Assuming we already have a hit on the 100. We already have some heat on the 100, and then when it reached the let's say there's already heat on the time is 100, and the heat is like something like 20 heats on 100-second time, and now the time has now the time is 400, right? Since we're using like a mod 300, right? So we'll see, okay, so there is something already in the timestamp, but at this moment, right, as long as this thing, the time, right, as long as the time is not the same, the stores in the time list is not the same as the current timestamp, then we know, okay, we we see we already in a new 5 minute cycle, right? In that case, we'll need to basically update update this the index with the current timestamp, right? And also the self count, right, of this index. We'll be using the same index, will be reset to 1, reset back to 1. Okay, and okay, let's see. So and else, right? Else means it's in the else means the current time, the current index of this time is the same as the timestamp, right? It means that means many we're seeing like the heat for the same time, right? So we simply just do a self count index plus 1, right? Let's say we're at 400, we hit 400 times 400 uh, at time 400 we have like several hits, right? So each hit, the first hit, right? So the first hit will be the first hit will be resetting this thing to time to 400 and also the count equals to 1. And the second time when this another hit on the same time comes in, the index is also 100, right? But at this moment, since we had already updated this time array from 100 to 400, then this one will be false, right? Because they are the same now. And then we just need to increase it, right? So that's how we maintain this heat time and count uh, list here. And then in the end, when we want to get the how many hits we need for the current timestamp, right? We just have an answer here. We simply do a for loop. We loop through all 300 of the time here in range 300, right? We simply loop through all 300 uh, buckets here, right? If, right, uh, if self dot time is greater, it's greater than than what? Than the current this time is greater than the time stamp minus 300, right? Then we know, okay, so this is the answer, part of the answer we need, right? And then we just do a self dot count I, right? And then we simply return answer in the end. All right, let's try to run it. Cool. Yeah, so it's passed. Basically, the idea here is that we want our uh, solution to be scaled, right? To accommodate like if there are huge number of hits per second. That's why we are using like a bucket to store the count for each for last 5 minutes, right? Only 300 because we're only maintaining 5 minutes 5 minutes count here, and then we use the index to index to maintain the count, and then when we try to query how many hits until the current stamp, we loop through all the 300 buckets, and then we check, right? And then we just summarize everything. Cool. I think that's it for this problem. Yeah, I hope you guys enjoyed. Thank you so much for watching, and I'll be seeing you guys soon. Bye bye.